take a look at some other vocabulary you're going to have here. When the graph is above the x-axis, we say it's positive. When it's below the x-axis, we say it's negative. When it's falling from left to right, like you read a line, like you read a sentence, it's decreasing. When it's going up, it's increasing. Notice this line goes, or this graph is decreasing in the red and increasing in the blue. Maxima or minimum, exactly what it sounds like. It's the biggest the graph can be, or the smallest the graph can be. Now, we do have something called relative minimum. What that means, it's the smallest in the neighborhood. So if I look at this point A here, notice every point right around A is bigger, so we say that's relative minimum, and this is relative maximum. Since I have an arrow and it keeps on going forever and ever, I don't have an absolute maximum. You're not going to have what we call a global maximum, and you're not going to have a global minimum. The end behavior is what happens to your graph as you get really, really big. So as x gets really, really big, what happens to your graph? And as x gets really, really small, what happens to your graph? That's what we're going to take a look at here. So on example 3, it says the graph shows the population Y of deer X years after the animals are introduced in an island. Estimate and interpret the function when it's positive, when it's negative, when it's increasing, and when it's decreasing. I want to know the x-coordinates of any relative extrema and the end behavior of the graph. Well, let's start here from the beginning. So we want to find out when it's positive and when it's negative. Notice, because we're doing deer, it's always positive. It's always above the x-axis. So in this graph, it's always positive. When is the function increasing? Well, it looks to me like it's increasing from x equals 1 to x equals 4, from 1 year to 4 years. So I'm going to say it's increasing from 1 to 4. When it's decreasing, well, let me mark that down. It's decreasing from 0 to 1, and then from 4 to about 6. Not quite 6, is it? 5 and something. So I'm going to say it's decreasing from 0 to 1 and beyond 4. And then let's look for any relative extrema. Well, we take a look at this point right here. That seems a low point, doesn't it? So that's my local minimum. Here we have a local maximum. So I'm going to say it has a local minimum at, we'll say, x equals 1. It has a local max at x equals 4. Now we want to describe the end behavior. Now this is kind of confusing on this one, because according to my graph, let me erase my other stuff I have on here first. When I look at my graph, I see this arrow, it's pointing down. So as x gets really, really big, like as x goes towards positive infinity, my graph is going to go down towards negative infinity, except we're doing a deer population. So in the year between 5 and 6, they ran out of deer, didn't they? There is no end behavior on this one because of the application. So we're going to say there is no end behavior. And that's what you're going to be looking at when you look at these graphs. We're not really problem solving. We're describing what we see. Let's take a look at example 4. It says Roberto and Tanner are each saving $175 for tuition to a summer baseball camp. Roberto begins with $45 and he increased and he received for his birthday and adds $10 each week to his savings. So after 13 weeks, he has the amount he needs in order to attend the camp and stops adding to his savings. Tanner's saving is shown in the graph. Compare the key features of the graph. So we're just going to do what we just got done doing. So we'll start with our x and y intercept. Now this one, you have an x and y intercept. It's at 0. They're both at 0. It crosses the x-axis at 0, crosses the y-axis at 0. So what that tells me? That tells me Tanner had nothing saved to start with. So the x and y intercepts are 0. There is no symmetry because there's nothing on the same, if I would draw a line any place up and down. Then let's keep on going here. Let's take a look. When is it positive? It's always positive, isn't it? It's always positive. And it's always increasing. There are no relative max or minima. And finally, let's do the end behavior. Notice as x gets really, really big, my y value gets really, really big. We call that positive infinity. So I'm going to say as x approaches positive infinity looks like back a sideways 8. Okay, we're going to say y approaches positive infinity because it just keeps on getting bigger and bigger. And those are the key features of our graph.